Recording in progress. This evening is a special evening. It's our 19th annual HBRC Challenge Phase 3. We do this 3 times a year starting in 2003. So this will be our 57th HBRC Challenge meeting. It's an all show and tell meeting. And without any further ado, we'll get moving ahead here. First thing up is robot news. Any robot news out there?
I'd just like to mention really quickly, it's sort of robot related. Al Margolis does not seem to be here today, but I went to visit him at the Moffitt's Historical Society, where they have a, I guess you could call it a robotic train. He's now in the process of trying to retrofit a bunch of old motors that have burned out, replacing them with servos to do the train switching. Basically turning it into a Raspberry Pi based controlled model railroad. It's really worth seeing. If you have a chance, go check it out. And especially if you want to volunteer with either writing code or doing some electronics, or if you have a 3D printer, helping to create some of the railroad track switches. So I just wanted to put a shout out to there. And it's actually pretty cool.
Yeah, there's a long-time connection between model railroading and robotics, so fair enough. In the news, NVIDIA's announced support for ROS. They're going to be incorporating ROS into their Isaac robot engine. GEMS had been a different framework, robot Isaac engine, and then GEMS was the packages. They have perception packages and machine learning packages and that kind of thing. I just posted a link to the to a Forbes article on that. Let's see, I'll actually swizzle over to it here. Robotics gets a jolt from Open Robotics NVIDIA partnership. There was one line in here that really caught my attention. And let's see here. Yeah, 2025, the global robotics market will reach, oh, here it is. According to data from Statista, the robotics market is projected to grow at over a 25% rate annually, an increase from 20% prior to COVID. So I've always thought this, but you know, one of the silver linings in the COVID situation is you know, bump start to more robotics as people want to be places without being places and stuff like that. And of course, everybody doesn't think anything about just popping up a Zoom meeting, us, for example. The other big thing in the robot news is Amazon's announcement about Astro. Now, did you catch that? Everybody knows the Astro connection, right? Astro is the dog from the Jetsons. Hang on here, there it comes. So this is an article here. Let me pop this article in the chat so you can look at it offline. If I can find the chat.
It seems a bit pricey to me for what it does. $1,000 if you buy it day one, and then it bumps up to $1,500.
Well, I'm looking for a telepresence robot, and you know, Time is probably the standard. I think it's 2,500, and otherwise the pad bot and stuff like that you can buy for, I don't know, $300 or something like that. So I think this is an interesting piece. I think it's a it'll make waves, and there'll be things because of this, and it'll be interesting to see how Amazon does with it. You can always go down in price, right? But there it is. It has a telescoping camera, and the main thing is it's able to navigate, so you can put things in it and tell it to go someplace, and it'll go there. I posted this link in the chat so you can check it out later, but it opens it up here at the bottom.
And
This is fun.
have you looked at the security aspects of it? I mean, everybody knows the Alexa devices are listening to you all the time, and there's some debate about whether they're sending personal information.
Yeah, I pretty much live online anyways. So, but you can always turn the camera off. You can always turn the camera and the microphone off.
Yeah, I think this is going to eventually be a way for Amazon to harvest data about you.
Oh, no doubt.
It's quite interesting.
So here's something I've always thought. My doctor even told me to put the blood pressure monitor on my robot. And you got a robot chasing you around, telling you need to check your blood pressure. Anyways, this has some of the technical details underneath. It's kind of cool. So that's the link I posted there. And I asked for an invite, so we'll see how it goes. When I get it, I'll do some kind of box opening or something. Any more robot news out there?
Camp, about the Astro, do we have any idea where it was made or what division within
China,
Amazon?
I'm sure. It's basically.
No, I'm sure it's manufactured, but I mean design.
I don't know. I suspect there's an element of Silicon Valley about it. I don't know.
Yeah, I wonder if it's a team that we know about.
I'm stating the obvious here. It's basically an echo.
I'll jump in here. It's pretty well known that there's a massive robotics team being done by Amazon, and most of us believe it was a Silicon Valley Amazon team. This is separate from the Zoox team.
Thank you.
But nothing official. We just that's the grapevine.
You say Silicon Valley Robotics team.
I mean, based out of Silicon Valley. That's all I mean.
A Google team, an Amazon team.
An Amazon team that's the Amazon has a large footprint in Silicon Valley, and so.
Yeah, this has been going on for 4
I
years.
actually know a little more, but I shouldn't say so.
Yeah, all the AWS infrastructure, all the routers and servers and stuff, I think for the most part come out of Silicon Valley. They have a lot of engineering here.
Yeah, and this is the Vesta project that's been going on for 4 years. Say, David, do you want to say something about this symposium on intelligent robotic assistance, disaster response?
Well, I don't have much to add besides what I posted. If you go to the site, it just came across my email links today that's going to be up there. It's free, so you can register and watch it online. Got some pretty big names in it, so I thought it might be interesting to folks here too, if they have time to tune into it.
Very fine, David. Okay, any more robot news?
Yeah, actually, so probably a lot of you know about it, but on October, I have to go look and see what day it is. October 20, whatever that Saturday is, 20.
Is it the 23rd?
October 23rd, there is basically a robot block party happening local here in the Silicon Valley area up at Circuit Launch. Basically the Silicon Valley Robotics folks are hosting an event all day, and those are always fun things to do and go to. So I'll put the link in the chat.
The 23rd is a Saturday, so.
Yes, and that was on the mailing list some time ago already.
Yeah, the Homebrew Club should have a pretty good presence there. That is exciting. Any more this is moving into club news now. Any more club news? We need a presentation for next week. So any of you guys that want to do a presentation, get in touch with Joseph Hetty or send me an email and we'll get you in there. We need a
What's this?
presenter for October.
When is the robot block party? I think that's next month. And
October
do we know if we're
23rd.
having a presence there?
October 23rd. That's what Jim was just talking about.
Oh, okay.
And Marco, I think Marco put a link in the chat, right?
No, that was Jim as well.
I just posted in the chat just now.
There is a link in the chat for the Silicon Valley Robot Block Party on
And
October the 23rd.
Andrea would love, some sponsor folks. If you've got, if you're from a real robot company, you could exhibit your stuff there as well. Always, you know what? It's funny. I put that in quotes, right? Because when I explain to my kids about, some of these activities and things you can go to, and I talk about, because I tried to get some kids to show up tonight. And I say, well, you've got the Silicon Valley Robotics, organization that Andrew runs that and blah, blah, blah. And those tend to be like real roboticists working at real companies. And then I say, and then you got this homebrew, which is like, they're roboticists as well, but mostly just crazy old people working on weird robots in their garage. And I make that distinction, which is maybe not fair, but like I make that distinction.
Jim, it's totally fair. It's, Andrea and us get along just fine. She runs the professional organization. We run the amateur organization, and we're great friends.
Yes.
And you never know.
And another thing is the car games are happening this weekend. So I don't know how open they are. They require the COVID vaccine, complete vaccination.
What is this, Marco?
The car games.
Car games.
Yes.
Cal Games, Western
Oh,
Robotic
Cal Games.
League,
Yeah.
Seal Craig's thing. And I don't know if they're still looking for volunteers.
They were at least until Wednesday, but yeah, not sure.
Cal Games, got it. Okay, very fine. Any more club news? Hey, okay, let's move on into the main thing here. Again, tonight, this evening, is our 19th annual HBRC Challenge Phase 3. We started this thing in 2003. Some of us were lamenting the lack of robot building going on in the club. At the time, we met at the Castro Middle School in Campbell, and we were meeting in the library with a lot of tables. And we observed that robot building coincided with contests. And so we had a line following contest and a maze busting contest, but these things involved setup and, winners and losers, and somebody was always unhappy. Wow, that tape is shinier than mine was, or gosh, I didn't think the maze was going to be that narrow, whatever. And so we knew we had all these robots in the club, demoed once and then sit on the shelf. And so we wanted to do something to get these robots off the shelves and being demoed. So it's like, okay, let's do tabletop soccer. And Bill Benson was fond of saying that is non-trivial. And sure enough, tabletop soccer, we start talking about, well, we'll put a net around the table to catch the robots if they fall off and so on and so forth. But, no, that's setup. We want something that's just no setup. And so that's when it was born, the Tablebot. A Tablebot is a robot designed to survive, live, and play on a table or pay the price. And so how do you do that? The same way you would eat an elephant, one bite at a time. You get there in phases. Phase 1, we decided would be go from one end of the table to the other and back. Phase 2 would be to push a block off the table. And phase 3 would be to push that block into a shoebox mounted on the table. And then we started doing this in the months of June. And now we do it in September, August, and March, June, and September. And so we're in September now. And so this is our third phase. we had it so that you do phase 1, 2, and 3, but now it's just like, whatever phase you're in, that's fine. Actually, we've got a certification aider. That would be Chris Mayer. He's going to certify whether robots are phase 1, 2, and 3, and we'll get a ruling on each robot as we go through them. Also, if you would, and remind me to pause and get kind of a glamour shot for each one, because these screenshots are what we'll use to tell the story. So to begin with, I'm going to demonstrate. Oh, let's start this up. Peter Lowe, are you out there?
Indeed, I am.
Before we get started, and before I forget, you said you have some some robot related food stuff. Could you show us or demo that for us?
Sure. Yeah. Just give me. It's
Didn't know
it's
you were
not going
gonna
to be.
Didn't know you were going to be first, did you?
Did not know that. No. Yeah. Let's see here. It's getting a little dark out here. I feel like you should show at least a little live stuff. But it's not going to be totally live anyway. But here is, it's sort of, this is a little torn apart right now, but you can see I'd shown some stuff a little while back where I was kind of playing with a dispenser and just kind of talking about this general space of food robots. That's pretty good.
Can you open that and kind of get your head in the picture so I can get a snapshot?
Oh, totally. Yeah. And I want to illuminate just a little bit because my phone, my laptop's having a hard time seeing stuff, but yep, let's see here. Get a little light on my face. All right. You see that?
Is that inside a refrigerator?
This is, yeah, it's a hacked refrigerator. So that's what I've been using as a test bed for this thing here, where I've been looking at, I'll just sit down outside here, looking at this kind of idea of the opportunity for essentially like these super vending machines that make food from scratch. So it's like kind of a restaurant in terms of what it's doing food wise, but it's sort of like a vending machine in terms of its footprint, and kind of the sort of the lower end of the price range in terms of capital cost. So I've been looking at that. Like I kind of followed some of the companies that had started up in this space over the years, and that was one of my observations, was the ones that were trying to go after the autonomous operation kind of did stuff like with universal arms or other kinds of robot arms that added about 50K to their BOM cost. And so they ended up with a very expensive machine, right, that then kind of pushed them away from a lot of the interesting areas that you might want to operate in. So I've been kind of thinking about this approach where it's less kind of some of the most exciting there's not a 6DoF arm in there that can wave at you. It's more more in the realm of like automation.
What's the name of your product again?
The working name of it is FreshBot that I've been looking at, and so
FreshBot?
Yeah, FreshBot. Yeah, and so the
what's it making again?
Yeah, so stuff in a cup is sort of the category. So things like coffee, smoothies, parfaits.
You could literally have your Septuagint Centennial cupcake in a cup.
Yeah, indeed you could. And I could demo for just a second here. Let me see. I have just here's like a little not live demo. Can you guys see this?
Mm-hmm.
Yeah.
Here's just a little demo of it, not pulled apart and being worked on. Just kind of showing like this prototype. It's a mix of technical feasibility and just sort of like kind of showing the overall experience. So a little touch screen. You can order, check out. It's got a little reader, card reader hooked up to it, and then this thing will kind of assemble your, in this case it's sort of configured for smoothies. So it gets you a cup and puts all the ingredients in the cup one by one, and the idea being that there's a big window, right? So you can kind of watch your drink or your smoothie or whatever come together from scratch. So that's kind of the approach.
Fascinating. Thank you very much.
Yeah, and skip along, blah blah blah. It's kicked over the other side. Just blend it up, and comes out. There you go. And there's a smoothie. So yeah, anyway, that's what I have to share tonight.
Thank you very
Very
much,
neat.
Peter. All right. Let's move ahead here. Actually, that would be cool for the used to in the first meeting. We'd always do the potluck dinner. So that'd be part of the potluck dinner.
Yeah,
Boom,
yeah, that'd be a
boom.
fun thing to do.
Okay.
Peter, how long you been
So
working
here
on
we
that?
go.
That's very impressive.
Oh, thanks. Yeah, it's I've been kind of hacking on it a little bit for like I'd say the past year, kind of in my free time.
It's amazing.
Thanks.
All right, I'm going to kick it off here with the with Buggy 3 and my Tablebot. So I'm going to switch this guy on, and he's going after the block there. And he's moving it into the box. Oops, he didn't quite get it. Let's try that again. Can somebody take a screenshot of this and send it to me later? He's dribbling it around on the court here. Come on, you can do it. Oh, almost. Let's try that one more time. So this is the original Tablebot trying to do phase 3. He's trying to move the block into the shoebox. Come on, one more. Oh, I'm gonna do it one more time here. And
that error is real consistent. Do you have a light or something that's distorting it?
oh, it is what it is. Yay! All right. What do you say, Chris? Is that a phase 3
That's
or
a
what?
phase 3. That is a phase 3.
All right. Has somebody taken a screenshot of this?
I got it.
You got a screenshot? Okay. Either put it on the Google Doc photo or send it to me individually. Secondly, I'd like to show Rodney Jr. Actually, before I do that, I've done some stuff in Pseudocode, and I'll put a link in the chat. Well, maybe not. Here it comes. Code. And there it is. So this is the pseudocode for the phase 1, 2, and 3. And I'm going to be running phase 2 here. Basically, this is a demonstration of machine intelligence where the robot's trying to discover the motion pattern with linear velocity. In a differential drive system, the only two motion patterns with linear velocity are forward and reverse. Everything else just rotates around a point. And so here, Control V. Okay, so that's the pseudocode. It's a Google Doc for the pseudocode. Let me share my screen. I don't want to share the screen. So basically, it's a tabletop robot with an Arduino that's monitoring this rear wheel. There's an emitter and detector. And as long as this rear wheel here is spinning, the robot's happy. When it stops spinning, it's not happy. So initially it's random. Can you see the robot? Are you able to see the robot?
Camp,
Yes.
Camp, the documentation that you sent the link to is not public, so we
Okay.
can't get to it.
Okay, I'll deal with that later. So this is Rodney Jr. At first, he's doing random motion patterns. And when he is in a motion pattern and discovers a response that's successful, namely linear velocity, he'll remember that. So the next time he's in that motion pattern and stalls, he tries the response that was successful. If it is still successful, it increments the confidence. If it's no longer successful, it decrements the confidence. So the trick here is really learning forward or reverse from a particular motion pattern, and then either from reverse or forward, learn the opposite. Now, the gamma model, when the robot is in a motion pattern for which it has no high confidence responses, it tries high confidence responses from other motion patterns before reverting to alpha.
Velocity.
We'll try them one more time. You gotta love AI experiments or demos.
So Camp, in the things that the robot can change are its motor, left and right motor values.
Differential drive system. And if you look at differential drive, there are 9 possible motion patterns, including stop, if you want to include stop as a motion pattern. But it's left wheel, forward, reverse, right wheel, forward, reverse, clockwise, counterclockwise, and then forward and reverse. And the only 2 motion patterns that let that little wheel spin are forward and reverse. Those are the only 2 motion patterns with linear velocity.
Yeah, so it has all those 9 things to it at its disposal and keeps trying them until it starts getting what it wants.
Initially, it's random. The beta level has a memory element to it, so it remembers what's successful and increments and decrements the confidence. So it's a type of reinforced machine learning. And then finally, the gamma, when it stalls and has no successful responses, it tries high confidence responses from other motion patterns before reverting to random. So here you can see the robot going back and forth.
Right.
It's not that the robot goes back and forth, it's that it learned to go back and forth. Okay,
What microprocessor did you say is on that?
it's Arduino.
You got,
And I'll get the pseudocode enabled and I'll probably post it to the mailing list.
you got that, you got machine level stuff like that running on an Arduino. I'm impressed.
Yeah, well, it's rather contrived and it's as simple as it gets, but I think it's a good demonstration of machine learning. Can somebody get a screenshot of this? Yes?
I got one.
Okay, very fine. And then finally, I'm gonna, our certificationator, Chris Mayer, what do you rank this? Level 1, 2, or 3?
I'm not sure which challenge that was going for.
It's
but
run
as
what you
far as
brung.
the run what you
It's run what you
I'll
brung.
give
And
it a-
I'll give you a hint. There's alpha, beta, and gamma, and this is a demonstration of beta.
Then that would be a level 2.
I would consider it level 2. All right, I'm going to mark level 2. Okay, and then finally, I've got a Floorbot here. The Floorbot challenge is a challenge where you Phase 1 is to go from one end of the room to the other and back. Phase 2 is to find an object in the room. And phase 3 is to fetch that object. And so let me go back to my computer here.
You get extra points if you catch a cat.
That's a dynamic obstacle. And so let me share my screen here.
We can't hear you.
Oh, yeah. My phone's in the kitchen and I'm in the other room, so bear with me. My card is crashed. Can I restart the plan?
You're a bit far from your microphone, Camp.
The map I created earlier and saved it. Floorbot run out here. But navigate a little bit. Got a camera on there. And camera. And we navigate the economy. Okay, this is map 2. And the garden. Camera on there.
Camp, can you hear us? Because we cannot hear you.
I share with this with a Floorbot phase 1. I'm gonna pick this guy and circle it so you can navigation formula. It has a waypoint mode. And
Camp, your mic is working, but you're really, really, really quiet.
I'm in another room, okay? So bear with me. Here's navigation 2. We'll go from that end and back. Now go there and go back again. And start the navigation. So here you have autonomous navigation from one end of the room to the other back.
And you understand we heard none of that while you were away.
That's fine. It is what it is. I tried to. Okay. So, anyways, that's the map, the navigation, the camera. Ooh, can somebody get a screenshot of that? Yes? All right. All right. What say you, Chris?
Got it.
Did I get from one end of the room to the other and back?
Yes, you did. That would be a phase one.
Okay, phase one. Thank you very much. All right, let me make a note here. That's okay, so that's Buggy got the 3, and Rodney Jr. got the 2, and oh, sorry. I got phase one with that. And I need to show one more thing and then I'll be done. And that is this. I did get Kerbit navigating north.
You're gonna play Achy Breaky Heart for us?
If you like. So here's
Not-
Kerbit navigating north. I don't know if the audio is going to play through here, but you'll get the concept. This is 2 Arduinos. One is focused on the GPS, and it parlays the direction to the second Arduino, which actually drives the wheels. And I'm using the RoboClaw 2A7 motor driver, but as you can see, the robot navigates in a northerly direction, although it's kind of a wavy path. Actually, I've got him driving between a 330 and 30-degree cone, with 0 being north and 180 being south. And it needs tuning, where you can see he goes to the 2 edges of the 30 and 330, and then eventually it evens out and he starts traveling. So here I am carrying him back. I face him south and put him down. Here you see he's turning around and going north. Nothing up my sleeve. I've realized I need to replace these tires with some taller tires so it can get across the grass. But I really like this Huffy Green Machine chassis. It's a kid's ride-on toy that's differential drive. It's got 2 switches that the kid presses and can drive it around. It can go clockwise and counterclockwise. But here, obviously, I've hooked it up to an Arduino and a GPS. And here I face it. I face it south, and as you can see, it'll turn around and travel north again. So basically, this is Kerbit Robo Magellan trial. What phase would you say this is, Chris?
Well, I give it a phase 0.5, but I don't think we have that, so I'll give it a 1. But what are your phase 2 and phase 3 goals that
Well,
we'll
it's
get
a
to see in
Robo
March?
Magellan robot, so he'll need to navigate to a goal and touch an orange cone. But initially, you know, we've got it going north, and eventually I'll program in the target coordinate. And the deal is that you just subtract your target from your actual latitude. If the target coordinate is higher than the actual, you need to go north. If your target longitude is higher than your actual, you need to travel east. And so now you know what direction you need to go in so that you can eventually get, the eventual goal is to get to a GPS coordinate. So I guess my phase 2 goal is to actually navigate to a coordinate. Phase 1 here is just traversing a particular direction. Okay, thank you very much. Let's see who is up next here. So that's a phase 1 for Kerbit. Damaris and the Humanoid Comedy Show. Come on down.
Okay, can you hear me okay?
We can hear you okay.
Okay, so we got an assortment of humanoids over here. I realized that when I was sitting here, you could barely see me because.
All right, we got to get you in there.
Okay, there we go.
Got you in there.
So right now, these humanoids are telling knock knock jokes. So I'll turn the volume on.
Who is there?
I see.
It's very slow.
I see you.
I see a big polar bear up ahead.
This This is my, I just finished work and dragged these robots into the room and turned them on demo. So,
knock knock jokes.
So that's not what I was working on this month, but these guys are turned on. But so normally I'm going to turn down the volume for that. But so normally what happens is these two guys are doing a comedy show. I'm sure I'll raise the volume for that. I mean, the speed, so it goes faster. So what I did this month is, I'll show you a picture. So my daughter built this in Move 2019. She built the first one when she was 12. And then this one was a couple years ago. But as you can see, it had no front over here. So it's just not completed. So she hadn't worked on it for a while. So she's very protective of her robot, but she did let me make a couple upgrades to it. So that's what I did, going from here to what it is now. So I put in the Connect camera here at the bottom, and then I got a screen for my Raspberry Pi, which I found around the house, and then I designed the frame for it. So it's 3-tone. It kind of blends in with the Connect, and it has a silver, black, and a blue. So integrated that together. And it had been a while since we did the software for those. So those are running Python 2.7. So this one's running Python 3.5. I loaded the OpenCV. The previous face recognition code was using Simple CV, especially with my welcome bot that's behind me out of the camera. So I didn't use the same code. So really the welcome bot, here I can turn the screen. Okay, yeah, this welcome bot over here, it's to greet people and say hi, hello, and it waves its arm. So considering that when we bring 3 humanoids, normally this guy's just sitting there doing nothing while the other 2 are doing something, I figured I'd upgrade it with the kind of the welcome bot functionality where it has an OpenCV running, and if it it has a camera in this eye, and if it sees a person, then it shows their face, and it has a greeting there. So with this lighting, I've been having trouble. Oh, so I just showed a face, so I showed the picture on the screen. Oh yeah, it saw the reflection of itself. So
Hey,
okay.
Dee, can you put your face beside the robot? I want to get a picture of you with your robot.
Okay. So here we go.
Download. Yeah, that's perfect.
There we go. So yeah, that was the updates. I was surprised. It was a lot easier than before to install the OpenCV. Normally I use a terminal window, but Raspberry Pi came with Tawny, which has a really nice feature on there to download and install packages. So it was a lot
You're talking
easier.
about something that you use to install OpenCV?
Yes.
What's it called?
So in the Raspberry Pi, there's an IDE that's pre-installed. It's not the old IDLE as
You called it
before.
something though. You called it something.
Tawny.
Please spell.
THONNY. So yeah. And it so it has a simple mode and it has a more detailed mode. And so you can find that in options to do the more detailed mode where it has a file, edit, view, run, tools. And under tools, it has manage package. So under manage package, I really just typed in OpenCV and it did everything, installed everything. And then I ran it and I downloaded a couple example libraries and it's running. So this is very different from previous experiences where I'm looking around and trying to, essentially the reason I looked into it was because I started downloading stuff and then I realized it was installing it on my Python 2.7 and not my 3.5 version. So if I use this IDE, then it's installing on the Python 3.5 version instead of the 2.7 version.
Hey, I got one. Knock, knock.
Who's there?
R2.
R2 what?
R2D2.
Okay. So yeah, that's the concoction of humanoid. So I plan on bringing it to the robot block party this year. So hopefully there's enough space at the homebrew robotics table.
I remember your greeting robot. You showed it as an arm bot one time.
Yes.
Very good.
Okay.
Very nice, Dee Dee. Thank you very much.
Thank you.
All right. Next up is Chris. Chris, what do we got there? Certification 8, or what do you say? Phase 1, 2, or 3 for the humanoid comedy show?
I give that a phase 2. It's pretty complete.
Phase 2 it is. Super fun. Thank you very much. All right, one of our favorite club members, Mark Johnston, come on down. Mark Johnston.
I don't see Mark logged in, so let's go to Ralph Hips.
All right. Moving
Can you
right
post
along.
a list of people on the chat, please?
Okay, bear with me. Ralph Hips, are you there?
I can post it.
Ralph Hips, are you there?
Yeah, the list of pre-recorded people are there, and then we'll ask for other
Here we go.
after.
Ralph Hips, you're on.
Yeah. Here we go. Can you hear me now? Sorry, I was
I can
muted,
hear
I
you
guess.
now.
Yeah, so I just have a couple of quick things to show, one of which is a video. Can I share a video real quick?
Surely. please.
Let's see
And
here.
stop calling me Shirley.
Surely, exactly. So can you see this video?
Not
I
yet.
can't see it yet.
Yeah, not yet. Okay. What do I have to do to share? I'm not familiar with. I'm not
The
sure
green
how to
button.
share yet.
Are you on your phone or your
I'm
computer?
on the phone. I'm on the phone.
That's a good question. I don't know how to share on a phone. I don't know if you can share on a phone. Do you have it going on the computer also?
I don't have the Zoom going on the computer also, but I could arrange to. So yeah, let me show you just one other thing. Let me just flip the camera around here real quick and see if I can show you something I've been working on. This is a lot of the Scans guys that went into the Scans Kickstarter will recognize this top of this thing as the Scans LiDAR. So what I've done is basically hooked it up to a stepper motor and just scanning back and forth in about a plus or minus 45-degree window. And that's going to go on top of the tank chassis here. I've got the motor drive working on that, and then I'm going to use the scans to basically do navigation on obstacle avoidance. That's what that's about.
Hey, Ralph,
Yeah.
can you kind of get behind that some way and get a shot of the robots with your head in it?
There's a share screen on an iPhone. You just tap it. What happened, Ralph?
Thanks for posting the list, Jim.
Yeah, you did it. We got both of them, or two people did.
Ralph, I think you muted again.
Ralph, you're very muted.
Now I'm really muted, huh?
Ralph, there's a share screen. If you tap your phone, there is a share screen.
I'm sorry, say what? Share
Look,
screen.
if you tap and the green button comes up, just tap it with your finger.
Tap with the green button comes up.
Well, at least that happens for me. It's an iPhone, unless you have something different.
I'm on iPhone 7. That green button. What is that? Ah, is that what you were looking for?
Right. If you want to share the screen, you tap it and the green button pops up. Not that green button. The share screen button. It comes up and see my phone here? See, tap and it pops up.
Can't see your phone.
Maybe he should. I'm Messerschmitt. There we go. See?
There you go.
Right there. Take a look at that. I'm going to tap it and then it pops up on the bottom. There's the green button right there.
Yeah, okay. Share content. Okay. Let's see.
Beyond that, I don't know. I've never used it to share.
Got it. We're making some progress here. Okay, let's try this. Okay. Can you guys see that so far? Getting ready to show a video?
We still see you.
You still see me. Let me see if I hit play. Maybe, can you see this now? Still
Are
see
you
me?
seeing it on the phone?
I don't think you're sharing yet.
Okay.
Do you want to try to get it on the computer and check back in?
Oh, that's a thought. Yeah. No, let's see. Yeah, I don't know. I'm not sure. I really know how to share well here.
I think you basically tap it, share screen, and then go to photos and then pick a video. That's what I think, but I've never tried it.
Yeah, that's what I was doing. So well, let me take somebody else go ahead and I'll take a
Is it a
stab at looking at
YouTube video? Is it a YouTube video?
No, it's video I took on my phone.
Okay. Okay. Let's move on. I want you to go back to your scans and your robot there. Let me get a shot of you behind your robot when you get a chance. But if you'd log back in on the computer so you can share the video you want to share, okay?
Yeah, okay, let me see if I can set
All right,
that
we'll
up.
check back. We'll check back
All right.
with you.
Okay.
Ralph Hips, ladies and gentlemen. Kevin Chow, you out there?
Yes, I am out here. Can you hear
Are
me?
you ready?
Yeah, I could set up here.
Let's see,
might need
Ralph,
some,
have you got some kind of screen? Yeah, I think you managed to screen share because your
might
screen's
be some
staying on all the
background
time.
noise. Yeah. All right. So.
Okay, we see you now.
All right. So yeah, right now I'm at circuit launch. It's my project. We actually switch my camera around here. I'm on my phone.
Hey, Chris Mayer, can you put a spotlight on Kevin?
All right.
Camp, do you think you can mute? I think we're getting extra echoes out of your phone.
All right. All right. So you guys, you see me? My hand. Just make sure my front camera is working. Back camera is working. Okay, I'll see if you guys see that.
Yep.
Yes, you're
yeah.
on.
So basically, this is my project. It's a bit of an upgrade, somewhat from last time a bit. So last time, like I showed this thing. It was you know, I used like real sense cameras, and I since then replaced it with an OP camera. And I've also like shared this project too on like when I was on the Reddit Robotics showcase, and I can show you briefly a video of that. Just kind of do this weird awkward
Kevin, before
thing.
we get too far, can I get you to pose behind the camera and let me get a screenshot?
Yeah.
Pose and behind your robot. I want to get a shot of you behind your robot.
It's awkward. I'll switch my camera back so I can see myself. Right. Gotta go with this.
Get the camera, push it out so we can see the robot. There we go.
Yeah. Hold on. Let me just move this a bit forward.
Don't drop the robot.
Yeah. See me now?
That's good. Okay, go ahead.
Right. Awesome. All right. So let me flip my camera back. Yeah, anyway, as I was saying, like I presented this robot during the Reddit Robotics showcase, and this was what that iteration looked like when I still had the real sense cameras. I was basically doing kind of a, you know, obstacle avoidance kind of thing where, you know, you seize an obstacle, it turns left. Let me just fast forward here. Yeah. Yeah, I'm just like holding up boxes in front of it, or it's a. Just realized you can't really see because I was covering it a bit. Hold on, this.
So is this a quadruped?
Yeah, it's basically a modified toy that I put Raspberry Pi on top of to control it. Yeah. Fast forward to the. Oh, I mean, I can't find that place. So in the video, but I guess you guys can always watch that. But I also like was planning on showing the actual like current setup here that I have. So let me just put this down on the ground real fast.
So this is done with a Raspberry Pi?
Yeah, it's a Raspberry Pi 4. And it has a bunch of things on top of it. It's motor, driver controller, battery, OAK camera, which replaced my WSense cameras that I had on
Are you
previously.
using RAWs here?
Yes, I am. Well, I mean, kind of. I plan to actually use it a bit more intensively. This is kind of what my setup looks like. I'm currently VNC'd into it on my computer. So yeah, a bunch of stuff opened up. So I don't really have it like autonomous like working yet, since I upgraded to the new camera.
So you're just doing like a teleoperation?
Pretty much for now. Yeah, and I can also like I can also, I guess, show you like the camera output as well. I just run things real fast.
Can you make the robot walk?
That is what I'm going to do right now, just after I run
right.
these things. Yep. I'm just teleoping this to do this RTT steering thing. It's kind of a lazy way of doing things, but yeah, it's what I have for now. Just gonna flip this on, engage the. Hopefully this doesn't like flop over like it did last time. It kind of does that sometimes. So gonna just turn it left and right at first. All right, and now to walk forward a bit. Yep, that. And it flopped again. Ha!
That's awesome.
Yeah.
Very nice. All right, Kevin.
So yeah, I guess that's what happens when you like, I guess, put a little awkward setup.
No. There we have it. Red. Big red.
I can also show you real fast, I guess, the camera like output that I have my OAK if I run the, I guess, the example. But yeah, this what I'm planning to do with the camera is actually I don't have it yet, but I guess make use of the camera image recognition stuff, and yeah, that's what's in front of it currently. That's my. It's currently looking at some chairs and the other robot that my company is currently making. That's currently in front of it, and yeah, I plan on using this information somehow. As for how I'm going to use that, I haven't exactly quite figured that out yet, but yeah.
That's awesome. Thank you very much, Kevin Chow with Red. All right,
yeah.
Chris, that's a run what you brung. What level do you think that is? What phase?
I'm not quite sure. What do you think you'd give yourself there as a score?
I think we call it a work in progress.
Yeah, I think I probably like give myself like a 1.
We'll call it a work in progress.
And what's the level 3 goal?
Level 3, I suppose it's I guess some sort of like a autonomous move to a specified location kind of thing.
Very fine. Thank you.
Yeah.
We got to move along here. Sergey, you out there?
Yes, I will need a spotlight for my camera.
Okay. Can you spotlight Sergey? Yeah, there you are.
Okay, so basically what I am bringing here is that little toy robot. It started as a find in the thrift store.
Hey, Sergey, can you get your face in there so I can get a glamour shot?
Well, I mean, let's see what the glamour is. Okay.
Get your head a little closer to the robot. If that's all we got to work with, I guess that's all we can
Yeah,
do.
that-
Go ahead.
Okay, so basically it's a relatively cheap store. New it is $30. In the thrift store it was $5, and it is built like a tank. I mean, literally, not only the threads, the tracks that you see here, but I mean the robustness of this platform, good motors, you know, a lot of room. And a nice bonus to have is these encoders. And they are pretty precise. They are not very kind of high frequency types, but they provide very good feedback from the tracks to the microprocessor. Now, what I did is I supplied it with two microcontrollers. On top of it, you can see a Raspberry Pi Pico, and here Arduino Leonardo hides in the bottom. Leonardo drives camera and something else. Anyway, and the sonars here. Now it connects to Raspberry Pi Pico through a serial, and I had to kind of convert 5 volts serial from Leonardo to 3 volts using just 2 resistors. Don't forget about that part, you know, 3.3 volts Pico. And then I have IMU here, and basically that's it when it comes to the for the sensors. Now, what it does, the Pixie camera here, which is connected to Leonardo and then through serial is connected to Raspberry Pi Pico, it basically detects colors. So if I have an orange ball, it will be signature 1 color. If I have a yellow ball, it will be signature 2 color. And basically what it does now with all its, you know, mighty intelligence, it chases the color balls, nothing else, nothing more. So it boots and it blinks the, okay. Too close, a little further. Of course, it doesn't have any sensors to look down to the edge of the table.
It's not a table bot.
No, not at all. Okay. Anyway, let me put it back here. The idea was to kind of find use for Raspberry Pi Pico. It is a very powerful microcontroller. It does have 8, you know, channels that you can program with some simple code. The interesting part is that Arduino IDE in its latest incarnation supports Pico very well. For example, that IMU, the 9250, works just fine out of the box, you know, standard library. The motors can be driven easily, encoders, interrupts, all that attach interrupt, which is kind of touchy in terms of...
Sergey, pick up your robot one more time. Let me get one more snapshot, okay?
Okay.
Beautiful. Thank you very much. That was awesome.
Okay. So basically, I have that code written in Arduino IDE language, And that's very easy to, you know, kind of play with, modify and stuff like that. And
Thank you
that's
very
pretty
much.
much it. The idea, I mean, ultimate goal is to try a couple of things, maybe in subsumption architecture, maybe in behavior trees. And when I'm comfortable with the code, move it into the lawnmower, you know, into the bigger robot.
What phase we got there, Chris? Certificationator?
Well, I'm gonna ask the same question. What are your plans for level 3 to add to this robot?
It's a work in progress, you know. I mean, I'm not, you know, within the constraints of any competition.
Yeah, yeah. Our stock and trade is functioning robots. Works in progress are good for partial credit. Thank you very much, Sergey.
Thank you.
All right, moving right along. We got to move this thing on, folks, because we're Scott Horton with ElsaBot. You're on.
Hi, everybody. Yeah, it's yet more of ElsaBot type stuff. This time it's the final video for the OpenCV AI competition, the one that was submitted that lost, so it didn't win, but it was fun anyway. So I guess if I can get the screen, I will show this video. Let's see.
You have the ability to share your screen?
Okay. All right. Can you see that?
Yes.
Okay. Well, let me just skip onto the video. I'll show.
Hi, I'm ElsaBot.
I'm just going to show part of this. I don't want to belabor the point, so we'll just do the first little game. So I'll let it play a few minutes and then.
Heavy on the show, light on the tell.
Hi, I'm ElsaBot. I was created by Team Grand Play for the OpenCV AI.
Yeah, we're not seeing the video.
I hope to spark an interest.
You're not seeing that?
I'm seeing your screen, but not a video.
Huh. Wonder why. Let's see. Oh, let's see. Maybe I've got to choose the browser's window.
You want to carousel to a different screen, maybe.
Same screen. Let's see. Okay, let's see here. Stop.
You have to choose the right window or.
Okay, maybe I chose a window a minute ago instead of. Yeah, because it's not just the screen. Let's see. Chrome. Let's see. What do you see?
Now we see a video or a potential video. Yes.
Games for learning and fun. Allow me to show you my game. The first is Robot Hide and Seek. Hi there, Caroline. Hi. Would you like to play a game? Yes. Okay. Do you want to play Robot Hide and Seek? Yes. Yay! Great. Let's play. Hold on while I get ready.
So at this point, so the robot's set up where you can tell it any number of points in the house to go and search in this game. And so you can see on the map, it's showing those by the numbers. And so what the robot's going to do now is figure out where the closest point is, and then it's going to just kind of sequentially go through those points, searching, once the game starts here. And it's showing you on the map where it's calculating.
So this is a create with what, an OAK camera?
Yeah, so it's an OAK on the top and just a bunch of servos, so it can,
Is that an RP LiDAR there?
Yep, that's what's on that's doing the LiDAR. Yep, and so you can see in the lower inset there, that's what the camera is seeing, of course, and on the map you can see where it's searching. So it's at location 3 right now, and it's going to scan
You're
its
using
head.
ROS 2, aren't you?
Yeah, this is ROS 2. I've got 2 Raspberry Pis. I couldn't do it with one because the nav stack seemed to take too much CPU, so I just threw another one in there. That's the beauty of ROS. It's distributed processing, so just throw a processor in there and it just works. And so the video will speed up here, so it'll kind of get going. But the gist of it is using a mobile net SSD to do object detection. It's really only caring about people, so it's just scanning, looking for people, and it's talking as it goes, saying, "Hey, I'm looking for you," all that kind of stuff.
So it's a create, huh? An iCreate?
Yeah, it's the Create 2, the Roomba base, and which is pretty straightforward to use, just serial port driven.
I'm still looking for you, Caroline.
And so I'm using a behavior tree to control all the game, the game menuing and, all this control here. It's just a behavior tree. And I'll post the GitHub to it. So if anybody cares, just want to. Yeah, so I'll stop there. There's another game that's probably not as exciting, but I will point out the GitHub. And so if you go to RS Horton and go to the ElsaBot repository, you can actually find the report that I did for the project that I turned in. And that report pretty much gives you a full overview of the project. And let's see, you probably can't see it if I bring it up. You don't see that, do you? So
We see your GitHub.
yeah. So anyway, there's just for the sake of time, if you're interested, you can look at that PDF and it'll kind of give you a lay of the land of the other repositories here, because it's with it ROS, it's a distributed type design. So there's a repo for the node that runs the perception, that does the object detection. There's a repo for behavior tree, and there's the voice input output, all that stuff. So if you read the document at the appendix, it'll kind of list the repositories, and then of course you can poke around and figure things out too. But hopefully it's useful to somebody. I mean, the behavior tree stuff has proved to be pretty handy to craft some pretty nice little behavior logic together. So anyway,
Scott, is the ElsaBot nearby you there physically right now?
no, unfortunately not. Sorry.
All right. Can I get a screenshot of your face anyway?
Oh, that would be terrible. Let me just put a screenshot of the video up here, and you can go back to the beginning here. How about that?
And that definitely qualified for a phase 2 Floorbot. You went to the other side of the room and you found an object.
Oh, there you go. Okay.
Phase 2 Floorbot says the certification aider there. Very good.
All
Thank you
right.
very much, Scott Horton, ElsaBot.
You're very welcome. Thank you.
That was awesome. Thomas Metzerschmidt and Simone, you're on.
All right, can you hear me okay?
We can hear you good.
I got a question. Which plays better over Zoom, a local video or a YouTube video?
That's a good question.
Go with whichever one you got.
It's streaming from your computer. So where you get it from doesn't matter. It's going to match what you see on your computer.
Okay, just a second.
Hey, put your face in there so I can get a glamour shot. Not that Simone's not glamorous enough.
She's gorgeous.
Yeah, we're gonna have to work with this Thomas Metzerschmidt character though. That's the best you can do. Good enough. Thank you.
Uh-huh. All right, let's see what we got here. Let's see if we can get this to go right here. I was gonna do it live, but things go wrong when you do it live a lot of times.
That's why it's so exciting.
All right, let's see if we can get this thing to share. Share, optimize, screen 2. Make sure I'm at the edges of the screen, I think. Is that it? There we go, and share. Can you see a gray screen?
Yes.
Good, let's start the video. I gotta build one of those one of these days.
Testing. Can everyone hear me?
Okay.
Am I coming through okay?
She coming through okay?
Yes.
Good.
Extra creepy. In a good way.
I am Simone. And I.
Okay, Simone, we fouled this up last time. So tonight we're gonna redo some of the lines from 2001, A Space Odyssey. Are you ready to try it again?
No, not really. Can't I just sing a song or something?
No, no, no. Let's go with the original 2001 script.
That was so very, very, very boring. Besides, 2001 was so very long ago.
That's not the point.
How about I tell a few jokes?
I don't think so. No, no jokes.
Stop me if you've heard this one.
Simone,
Two cannibals were eating a clown. One says to the other, "Does this taste funny to you? How do you make a hanky dance? Put a little boogie in it. You know why blind people don't like to skydive. It scares their dogs." A man with dementia is driving on the freeway. His wife calls him on the phone and says, "Sweetheart, I heard there's someone driving the wrong way on the freeway." He says, "One. There's hundreds. What's silent and smells like worms? Bird farts." It must have been an engineer who designed the human body. Who else would put a waste processing plant next to a recreation area?
thank you.
All right. We've got the comedy musings of Simone there.
Never mind. Through.
Are they laughing?
I hope so.
Then I'm through.
Simone, please don't ever, ever do that again.
Who? Not me.
That's it, guys.
That's as featured in Servo magazine. That's awesome, Thomas. Thank you very much. Hey, Certificationator, what do you rate that one?
I'd give it a 3. I mean, it's pretty cool.
Simone's getting a phase 3 from the Certificationator. Very nice. Okay. Walter Martinez, are you out there?
I am. I don't know how I'm going to top that one. I mean, that's the ultimate.
You hate to go on after Simone, huh?
That's the ultimate goal right there.
Walter
right,
Martinez, things I got now. Go ahead.
All right, so I'm just gonna give you a quick, very quick show. More on the show and less on the tell of things I'm working on. So I'm gonna share my screen. All right, so can we see my screen?
We see your screen.
Okay, good. Why don't we start with this? So I got robot stuff and more entertainment stuff as well, but let me show you some of the kind of robot related stuff. So, you have those mixed recycling and, those bins at work, and people get confused where to throw away their recyclable or their landfill trash and all that. So a student and I created this little trash recognition system. It uses a Raspberry Pi, and I bought a little screen for it, and I made a little case for the Raspberry Pi, added some buttons, some LEDs, downloaded some MP3s, and I'm using a Lobe for machine learning. It creates like a light TensorFlow file.
What are you using for machine learning?
What's that?
What are you using for machine learning?
It uses TensorFlow on the Raspberry Pi, but we use Lobe to create the model. So we feed it a bunch of photos. It creates like a TensorFlow light file, and then we load it up on the Raspberry Pi, and then we have a Python script, and the script basically loads this whole system up, and then basically when you show it trash, it'll tell you with the camera where to put it on, what bin to put it on, recycle or landfill. And you can train it for things like hazardous waste and other things as well. But let me show you real quick. So it told, I don't know if you heard it, but, oops, sorry. So this is a clean plate.
There you go.
So it's said to put it on the recycle. I also have a video clip playing, you know, information about the university and the recycling group and all that. This is for, I work for California State University, Long Beach. And so I'm an IT manager there. And every now and then I teach a basic robotics course, but this was a cool project. So we figured it out, you know, and basically an LED flashes tells you where to put it. And also the Muppet, the Grouch guy from the trash can, you know, I'm using his voice to say trash or recycle. So it tells you with a voice where to put it, or it gives you an LED flashing of where to put it. And it's basically touchless. So you basically, with the trash, you can just press that button. You don't have to touch it with your hands. You press a button with the trash. The camera is right there next to the button. It tells you, you know, it recognizes the item, and then it tells you where to put it. So it's pretty neat.
Very cool.
So yeah, so then I have this recycled paper also, and then it, sorry, real quick.
Takes a snapshot. It's gonna tell you where to put it. Recycle. You can grab.
Then it tells you trash if it's trash and all that.
There's actually voice in there.
All right, so that's a little cool side project, just for fun. I had a little extra, you know, R&D budget to play with.
Walter,
All
how big is the image database and where is it hosted?
It's very tiny. You can just it's hosted on the Raspberry Pi on the little memory drive
So
on the
thousands of images or even less?
I have about 10,000 images that I grabbed from a database of trash. Yeah.
The trash database.
Trash data. Yeah.
How many items can it identify?
Right now, I only have it identifying 2. So just recyclable or trash for landfill. But it can be custom. You know, you can use Lobe, which is this product, and you can customize as many items as you want to identify. It's up to you. But it was kind of fun to play with it. I mean, this part is the easier part. I guess the hardest part, because I was trying to learn Python, was to figure out some of the pins on the Raspberry Pi. This was my first Raspberry Pi project, and I was trying to figure out the pins and, you know, how to connect the LEDs, how to turn in. And actually, it wasn't difficult at all. So it was pretty neat. All right, I have a lot of things to show you real quick.
Okay, you got 3 more minutes.
Oh my gosh. Okay, then I'll go directly to the important thing here. Here's a little robot. This is the iPack robot, or PackBot from iRobot. So I had to learn how to drive this guy. I get a call from a friend who owns this robot and another police robot, and he gets gigs for movies. And he said, "Hey, would you like to drive this robot in a movie?" And then I didn't know exactly what it was, so I trained myself for about 3 days to learn how to drive this thing. And then we did rehearsals, and then I figured out what the movie is. And the movie is called 892. And it's going to come out next year. It's a real movie with a big budget. It's about a soldier who comes back from the war, and he's got some mental issues, and he goes to a bank and robs the bank because the government only gives him $892 a month. That's why the movie is called 892. He can't survive on that. And this is a real life story, by the way. It happened here in the United States. The guy gets shut down inside the bank while he's robbing the bank, and he's laying dead on the floor inside the bank. And the SWAT team comes and brings these two robots. One robot, which is this one, cuts the strap of a backpack that the guy is carrying. And he's laying on the floor with a pool of blood. This robot cuts the strap of a backpack, and another robot pulls the bag out of it. And we go out of the bank, and then we put the bomb, the bag. We think that there's a bomb in the bag, so we put it inside this giant metal ball to defuse the bomb. And so anyway, so I had to learn how to drive this very well, because I needed to lower this, and we added a pincher with the remote control, not a pincher, but an actual cutter. And we needed to lower this all the way down to the floor to be able to cut the strap. And so I had to learn very quickly. And just so you know, the main actor in there is John Boyega from Star Wars. So I got to work with him, and it was an amazing experience. We did it up there in north of LA, and we had to close Topanga Canyon and all that. And it was a big production, big movie. And I'll show you a couple of photos. That's my garage, by the way. I won't be able to even show you any of that, but I'll show you something. A couple of things about that movie. Oh yeah, it's right here. Right there. So basically, I'm actually in the movie. I got pretty lucky. The director just kind of invited me to be in the movie. So I'm wearing this police uniform.
Awesome.
And I'm just driving those robots. And you can kind of see a little bit of a...
So you get to go put a costume on, casting call, the whole 9 yards, huh?
Yeah, the whole 9 yards. You can see all the costumes on the back here from all the...
Are you gonna get a screen credit?
Maybe it'll say robot driver or something like that. Well, they
That's
call
badass,
it
Walter.
puppeteers. Yeah.
Police officer, SWAT team member number 5.
Yeah, but it was
guy number 3.
It was so, I was so nervous because I could have hurt him, the main actor from Star Wars there. So I was a little bit scared to do it, but man, what an adventure that was.
All right.
But anyways, there's like a million.
Stage, screen, and Broadway.
Yeah, I also do other Star Wars characters and all that. But anyways, there's too much to show. There's a lot of projects, so I'll leave it there. I'm just gonna say that the one thing that I am working on is the AWS Deep Racer. So I'm learning how to use reinforced machine learning with this little car from Amazon. It's got a LiDAR and it's got a couple of cameras, and it uses deep learning, reinforced learning.
So does it actually look at the track and try to follow the lines and stuff?
It does look at it, but you have to train it. So they give you, you have to train it for a bunch of hours, and then it basically, the bad thing about this is that it only learns on a specific track. So if you want to use another track, you have to train it on another track and all that. So it's a race. It's an actual worldwide race. And you put the car in here, and then the car goes as fast as possible to finish that specific track. So that's the boring part. But the cool part is that you get to learn how to use all these AWS products and machine learning. And there's a million concepts and just concepts that you have to learn, and vocabulary, and it's so involved. I mean, this is like the donkey car, but it's a donkey car on steroids. Got a cool LiDAR and all that. But anyways,
Walter Martinez Marconi, folks.
Right. Thank you.
Thank you very much.
All righty.
Next on the list is Jim Denuzzio. Jim Denuzzio.
Hey. All right. Well, first, I think since my the social distancers video final submission was already aired on here, so I posted the link to that. in the chat. So today I'm going to show a video I just recorded, and I'm working on the next sort of a very similar feature for Orange. It's a waiter functionality to deliver drinks, and several of us are going to be appearing at the at this Long Beach Aquarium of the Pacific next week, and they're having a little robot showcase and a lecture. So I need to be able to deliver drinks, at least just a couple anyway. So I'll show you this video. It's very quick.
Did you print the cup holder?
No, so yeah, I found a cup holder online that fit perfectly on my tray, as you can see there, and with, you know, just barely, but I needed something to be able to hold beers and cans of soda reliably and stably with a robot bouncing over the floor. So this is at least the first attempt. And, you know, they're not going to be open drinks at this point in the phase of this prototype. So let me show you. So it's this is similar to the functions of last time. It's got its OAK-D camera at the top there. It's going to recognize the drink and then the person it's delivering to, and know where the person is in space in order to go up to them. In this case, it's going to deliver, and it's your voice activated and all that. So let me just play. I can talk over it. Orange, take this beer to Jim at table 1.
Please place the beer on my tray.
Hopefully you can hear that volume level.
Yeah.
Is there a sensor in there that tells there's a drink?
Oh yes, the camera is using the camera.
Okay,
uses
I will take this beer to Jim at table 1.
The camera is using YOLO V4, a machine learning model that knows 80 objects. So it thinks that that can is really a cup, but I don't care. As long as it knows it's you know, it's one of the things it can recognize. It recognizes bottles and cups. So I just play back whatever you said it is in this case, but it's checking to see if it's gone or it's there. Now it's looking for me. I'm sitting in the table, and you'll see the camera goes back and forth a little bit.
Hello, Jim.
Trouble with chair legs?
Jim, I have a beer for you. Please take it.
Thank you.
You're welcome. You know, I'm only doing this until I get discovered. I want to direct. For now, it's back to the bar.
That's my entry into the humor category. Not too good, but so I've put a few jokes in there, like randomly, or you know, about being a wannabe director and a filmmaker. So this robot has a night job, you know, got a day job and a night passion. Screen sharing has stopped the video. Oh, okay, thank you.
Do you have any trouble with table legs and chairs?
Well, you can have problems with those, but the robot's using SLAM, using the LiDAR, and you know, it'll see the legs of the table or the legs of the chair, and if it sees you know, if the legs of the chair are too close together, then if the robot couldn't fit between those legs, then the robot won't go there. So in most cases, unless it's a really wide chair, giant chair, robot will not attempt to go near even those little, you know, go between the legs. You know, you see what I'm saying? So you know, that is usually not a problem. But in addition to the LiDAR, I also have a depth obstacle avoidance system, but I'm not showing that today.
You're using the OD camera too, right?
Yeah, well, that's what it was. You were looking at the OD camera, and what I want to now show you, you can see my other screen. I've got my cell phone now pointing at the big orange live. So what I'd like to show you is briefly here. I have the next feature I'm adding is recognition of people essentially. So, whoops. So what happens is there's a model you can train, there's a model existing that it does a human identification. Well, here, let me show you a little tell here. This facial model runs actually 3 different models. A facial detection model. Can you see you can see Luigi there, right? Or Mario, or whatever. Yeah, it's Luigi.
Big orange going into a room.
Right. No, I mean, do you see the
I see your screen there. It looks like a picture of your screen.
let me try it. You can never tell what you're doing. Let's see here. You see this, this is the facial detection model. You see the little character there.
Yeah.
Yes.
So it's actually running 3 different three different models. The facial detection, which just finds a face. Then it does a head pose, which rotates the face to a normal orientation, and then it runs the results of that into this mobile face net. And this thing was trained. These are all available through the OpenVINO, which is from the Intel's Movidius Myriad processor. So these trained models are trained by the facial, they're trained with the features of the face, like the eyes and the nose, and they calculate the distance between those and essentially create a bunch of numbers that they could compare with another face. And they use what's called a cosine difference, which is like an angular difference. So that's how it can essentially tell whether a certain face is yours or another one. And what you do is you train it by pointing it or putting it into training mode. Then it will learn who you are. And you give it your name. And so you do that with a few different people, and then you'll get a database of a few people. Can you see the text now?
Luigi is easy to recognize, though.
What's that? Oh,
Luigi's easy to recognize.
Yeah, right. But all right. Let me turn. I want you to be able to see the text now. Do you see the screen here? I have like 5 people in the database, and what I'm do now is I'll run live here. Run this the facial detection system that I set up. Now, yeah, can you see the video of me on the screen?
Yes.
Yeah.
You see it says Jim there, right? Above my name is 70%. Now, if I put somebody else here, you see how it says unknown?
Jim, it looks like you have me in there. Would you mind, can you look at my screen right now and see if it knows me without my glasses?
Oh, right. Oh, well, I guess I could. It's kind of hard. Where are you? Well, unfortunately, the camera's on the robot. I probably, I'd have to pull it off and.
We need to keep this show rolling.
Yeah. Let
Chris,
me.
What's your ranking there, Certificationator?
So I wanted to show you that then my next stage is going to be putting this technology into the robot. So if there are 2 people at the table, it will know who's who.
What do you say, Chris?
Thank you.
Thank you.
Yeah, cool. Well, that looks like a level 2 to me. It's very functional, and it looks like you've got level 3 mapped out already. So we're looking forward to seeing
That's a
that.
level 2 Floorbot. You spotted an object in the environment and recognized it.
Yeah. Level 3 is hard. Yeah, in a Floorbot, you have to pick something up.
You would have to fetch it. Okay, very fine. Thank you very much, Jim. That was awesome.
Thank you.
Dillo, you're up. Something new.
Okay. Okay. Actually, it's after tonight. This doesn't really feel like something new. I feel like I'm kind of like certainly not on the bleeding edge anymore. I was going to show off my OAKD on my on Tenacity. So I'm also over here at Circuit Launch tonight, along with I think some others were here earlier. So let me just unplug the laptop.
Can I get a
here.
glamour shot of you alongside Tenacity?
Yeah, give me a second here. So let's go down here like that. I don't know if you can see that or not.
Wow.
I don't know if you can see that. Can you see that?
Get a little closer to the robot and get the camera a little further away. How's your arm reach?
Yeah, I'm having to hold up my laptop here. This is like kind of heavy.
You're good. Fair enough.
Okay.
Go ahead. Thank you.
All right. So, so here is my implementation of the OAKD. I have it on a custom 3D printed stock. And you can see I've got like a little tripod screw in there. So this is this is kind of the current state of the robot. We've got sonar sensors. We've got a VLX 503 something, which is a for distance sensor. So that's a cliff sensor right there. To the other things that I've done recently, I replaced the motor drivers. I don't know if I did tell you about this last time. Replaced the motor drivers with VNH 5019. I finally got off of those L298 ends, and so upgraded to a Pi 4, and the OAKD is running on a Nano. So I have a Pi 4 and a Nano. Pi 4 is basically running the ROS Master, still on melodic, still on ROS 1, and probably will be there for a while because there's different goals for this robot. Let's see here. Okay, so demo. What was I going to show tonight? So one of the things that's, and this isn't really all that. Somebody showed the basic demos. I'm going to show Ross here. Somebody showed the basic the depth AI demos with the OAKD. So I'm going to show the Ross stack here. We have a number of demos. Actually, quit out of that here. Give me a second. I'll share my screen in a second here. I need to get my windows lined up. Okay. So yeah, let me share my screen here. Share screen. Hold on a second. I need to close a few windows here. Okay, I think we're ready here. Are those addressed to me? No, they are not. Okay, so share screen. And we will share the X terms, my terminal windows. Desktop 1, advanced. Okay, well, we're just going to go with that. Desktop 1, share. Okay, can we see this?
Yes.
Okay, let me go to Xterm. Okay, so I'm going to close that. So this is on the Jetson, and this is not going to be terribly exciting, but I think it's going to be interesting nonetheless. This is on the Jetson. You see the X term here?
Yes.
Okay, so we have CD depth AI examples. So we have a bunch of different examples. There is a MobileNet publisher, which runs MobileNet. There's regular RGB, and then there's YOLO. So you can run YOLO v4. So we'll just start with something simple here, and just run. Let's see, publisher. Okay, so it comes up, and then we can go back over here and close that, and then just RQT. Okay, so I mean, really simple. You have this is just the RGB view from camera. So it publishes, so basically, I guess what I'm getting at here is there's like a full ROS stack already up. So you can develop custom applications with the OAKD, but you also have access to like the full ROS stack. There is a depth, whoops, yeah, it doesn't. So it does that, it does depth, so we can bring this up into, it didn't like that.
Did you guys write this this stack for the OAKD? This part of the driver, the raw stuff.
No, this is already out there. This is in their repo.
Or is it newer? The ROS version fairly new because Brian Erickson had to like write his own because theirs was in bad shape.
Yeah, I'm just using whatever one they're using, whatever one theirs came with. So we want to go to MobileNet publisher. Color. This is Fox. This is another thing I wanted to show. This is Foxglove Studio. If you haven't seen this.
Not related to Foxy Ross.
No, this is actually really pretty cool. This is a way to visualize this is like a topic visualizer. It's sort of like a follow-on, like the inheriting the kind of inheriting the mantle of RQT, except that it kind of works.
Nice.
So you can take, you can drag frames and you can reposition them. you can add topics and you can delete topics dynamically. And there's different messages that you can get in here. So if you really had a, I don't really have one right here, but if you had like a LiDAR, it's like a 3D view. If you had like a robot state publisher view, you can incorporate that. So they're really, the cool thing I like about Foxglove is that it's really wrapping up like all of the RQT stuff, and it's trying to wrap up RQT and RViz and you know, like all the tools into a web into a like a, I think it's done in like WebML or WebAssembly. Anyways, it's like, it's all singing, it's all dancing, it's modern, it doesn't use Qt. It actually works. It's you should check it out. I really
That's
like
Foxglove Studio.
Foxglove-Studio. Yeah.
Very good.
Yeah. So this is the YOLO. This is the Ross YOLO package for.
You only look once.
Yeah. So one of the nice things about this is that you have like this topic right here, spatial detections. So that will just report back to you as a ROS topic. That will just report back to you the objects that it sees. So you don't have to stream all the video across to your robot or to your laptop or whatever. You can just say ROS topic, echo that, and so right now you see that it's not seeing anything. You see this is like detections. Here is null. Now if I go and I stand in front of the robot, you can see it just kind of starts going crazy. So you've got, I'm moving back and I'm moving forward, and here's a bowl. Here's a bowl, and here is I think canned air. So different. So just like I think it was Jim that was showing with his orange bot, it detects a bunch of different objects. So it reports to you what that object is, and there is within the YOLO library or within the ImageNet or MobileNet package, there's like an index for like, you know, number 37 is a water bottle, number 38 is, you know, a can of beer, number 39 is a cat, you know, number 40 is something, you know, number 50, like it will pick up, I think if I move my laptop over here, it'll pick up the laptop.
It's hard to see the detections. It's going by too fast, I guess.
Yeah.
Well, the point is that it does the AI and spits the information out in
Yeah.
the raw.
So there you go. It's detecting
That's
the
it.
laptop right there, if you can
Cool.
see that. So
Yeah, that's cool.
just to show you how quick that you can, you know, this is like really just kind of like ready to go here. I actually wrote like in true homebrew style. I wrote a little YOLO object detector here. So if you can see the script, and this is reading the data. This is subscribing to that YOLO special that object detection topic, and then it just, I mean, right now it just prints out, you know, detected objects, and it's kind of like, it's still going to stream by, but it's in kind of like a more ordered, humane
Cool.
kind of way.
Very
So
good.
let me just really quickly, I'm going to just run this here. And yeah, so that's still running. So, whoop, there's no, oh, okay, hold on. I was messing with it right before the demo. I was messing with it.
That'll
Okay,
show.
so that's okay. So it thinks it's detected something. So I'm going to go stand over in front of it over here.
Yeah, see, it said there was not, it doesn't say person.
No, it just gives you the object ID, or it should give you the object ID or
We're not
something.
seeing an ID either, though. It just says
Okay.
detected object colon
Yeah.
space at.
It's a work in progress.
What do you want for like a half an hour before the meeting?
Oh, that's pretty good then for a half hour.
So this, yeah, I guess what I'm trying to get at here is that like this really is just the topics that are presented or the data that's presented, the topics that they're using, the message formats that they're using, they're all kind of standard message formats.
Very good.
That you're using for ROS. So the end goal here for this little script would be to subscribe to that RGB topic, to take these XY coordinates and to, with OpenCV, I'm going to stop sharing here.
Dillo, okay, ladies and gentlemen.
Yeah, I'll wrap up here. So to just like, put a box around my face with a ROS image.
Hang on. Gotta get it. And there. That's your glamour shot.
Okay, so that's
Thank you
me.
very much, Steve. All right. Brian Dobie, you're on.
Could you get I need like 5 minutes. Could you do the next person and then come back to me? I'm kind of fixing stuff last minute.
Ross Lumen, you're on. Mike Ryan.
That's the audio.
Ross Lunan, you're on. Out of Canada. Ross Lunan, are you out there? It's midnight here on the East Coast. All right, Michael Wimble, Buck.
I'm in the middle of doing something, so I'm not ready to do a presentation.
Chris Mayer, Mottbot.
And for this, you cut me off early.
What can you do? Live shows are rough.
Okay, I'll kill a couple minutes while other people are trying to get their demos ready to go. This is Mottbot. Let me share my screen here. And this is actually a demo I did a while ago, but I wanted to show it off because I was inspired by Camp's showing his machine learning demo. So this is actually Mottbot knowing absolutely nothing about the tabletop challenge, and it's going to learn how to do it by itself autonomously using a genetic algorithm. So let me just play this video and I can talk over it while it's going. But basically it starts off just doing random things to the left and right motors. I got tired of the Mottbot actually falling off the table. So I built a table that had a black border and a yellow center and programmed it so when it gets to black, it realizes I'm off the edge. So it didn't actually fall. So it just does a virtual fall. So right now it's learning, doing random things until it goes off the edge. It gets points for speed. So some of the things that it learned first is just to spin around in a circle as fast as it can, because that's moving and not falling off. So then I had to change the goal to move forward as much as you get points for only forward speed rather than any speed. And it's just an example of be careful of what you define the goal to be, because it will do what you tell it to.
That would be linear velocity.
Forward linear velocity, exactly.
As opposed to
And
angular
it's
velocity.
learned, yeah, and so now you'll see it's learned that when the sensor goes off to back up a little bit. So it's just gonna So you'll notice when it goes, it backs up a little bit, but it still gets caught in the corner. So now it's going to slightly modify that. It's learned a little bit. So now it knows when the right sensor is off the edge to back up. It looks like it hasn't learned that for the left sensor yet, so it still favors rotating counterclockwise.
How did it know to back up exactly? Because that
It didn't. It basically there's 4 states. There's 2 bits, left and right, and it's either on or off the table, and then it moves into a different state based on which of the 4, what the 4 bits are. And so here you can see it's learned to back up when it goes off the edge. So there it is. It just took about a dozen tries, and now it's doing phase 1.
So it learned to back up because that put it in the right state.
It's actually turning. Oh, it is backing up.
It put it back in the state of being on the table, which is the part of the goal, right?
Yeah.
Linear velocity and staying on the table, right?
Exactly. Falling off the table is death.
I had a question about all of these ones. A computer sciencey question is, do you have a better random number generator than just the standard lib one? Because that would mean every time you turn it on, or you get the same seed value and all the same random numbers.
Well, unfortunately, this is an Arduino Nano, and it doesn't have a timer, and it doesn't have any memory. So when I turn it on, yes, it does go back to the initial same seed. I could have easily done things like set the timer, and the first time you fall off the edge. I mean, there's enough entropy where I could have done something different. So that's a good observation.
Yeah, that's interesting part of it.
Yeah, but anyways, that's a simple Arduino Nano using a genetic algorithm to learn Tabletop Challenge by itself. That's it.
Nice.
All right, we've got a MontBot phase 1 table bot using machine learning. Very good. Thank you. Hey, Ralph Hips, are you back? Ralph Hips, are you in the building?
I think he had to go eat, he said.
All right, no problem. Moving right along, let's see. Ryan, are you ready?
I think I got it right, but I need to switch to Zoom on my phone. Give me a second.
Audio is really Ryan, your audio is
Okay.
hot, way hot.
What do you mean?
It's very, very
Turn the audio off
staticky.
on the computer.
Lots of noise and very surgy.
Are you there, Ryan?
I guess I should just say the word terrible instead of hot, but
Are you there, Ryan? Turn the speaker on the computer all the way down if you're using your phone.
I'm here. Read the comments. Just a second.
You gonna be able to make it, Ryan? He says, yes, just pulling up Zoom on phone.
Well, that video is from 2018, Chris, huh?
Yeah, that was a talk that I gave quite a while ago, but I'm scheduled to give part 2 of that talk finally next month.
Yeah, a lot of us have never done
Are
that
you
before.
are you saying you're going to do the presentation in October?
Yes, I am.
Oh, that's exciting. Hey, we have breaking news. Chris Mayer's doing the presentation for October.
That's great. I've
So
never done
Ryan
it.
says he's almost on the phone Zoom.
All right, I'm in.
All right, Ryan, you're on.
All right, so hold on. Need to start streaming. Wait. Shoot, wrong direction. Oh my God. Audio and Ubuntu do not like each other, at least on this laptop. Oh my God. Ugh. How? Oh my God. I forgot. How do I fix this? There we go. Well, I guess I can only show one of these at a time. Wait. Oh no. Okay, yeah, it works. All right, you hear me?
Yes.
All right, so let me restart this. Is it flipped on your screens? Because it's flipped when I look at it from presenter view.
I see your computer screen. It's fine.
All right, so it's been fixed. All right, sweet. All right, sweet. They're both running at the same time now. I got the robot and I got the odometry.
Tell us what it is, Ryan.
Right now it's the initial stages of me trying to get odometry working on this. I realized at the start of this presentation, all of my math is wrong. So let's say my robot is on the floor and hypothetically speaking, exploring the room. Okay. Oh, shoot. It's moving around and such.
Are the wheels
Wait.
moving?
Oh yeah, the wheels are moving right now.
Show us the wheels moving.
Hold on, let me fix, let me change the frame of view. There we go. Now it looks like it's, now the robot looks like it's moving. There we go. All right, here are the wheels moving.
We see the wheels moving.
Now to show you the robot moving, hypothetically speaking, the simulation.
And this is Arviz or Gazebo?
This is Arviz.
Okay. So what he has here is Ross 2 stepper motors, wheels, and he's actually doing odometry with stepper motors.
Oh my Lord, my math is so wrong. Oh my man, I need to pay attention more in calc. Oh, my math is all wrong.
So is that the odometry topic there in that terminal window?
Yup.
Okay. So you can actually see it reading the odometry, and we have physical wheels turning on the robot, and it's basically being driven with stepper motors. So he's done odometry with stepper motors in ROS 2.
Oh, that is not how things move. That is not how things move. Oh my Lord, I need to fix this. Well, once I fix the math, this will work better, but this is it for now. Imagine the math works and it's moving how things should probably move.
Let's see the wheels on the robot moving again. We'll finish up with that. How about that?
Left. That thing's up. Right. Forward. Back. And yeah, that's the presentation.
So you're controlling that with teleop and basically looking at the ODOM topic. But the thing is that you've managed to do odometry with stepper motors.
Yes.
Okay, very nice. Can we get a shot of your face there, Brian?
Okay.
A glamour shot for our records here.
I look very glamorous right now.
Is that the best you can do?
What? I'm not. What do I do? What do I do?
Is that your best side? Thank you. Ryan Doby, ladies and gentlemen. Out of Texas.
Yes.
He's part of the Ross 2 meetup on Sundays. Thank you very much, Ryan.
All right, that's going to be, I'll give you a level 1 for Run What You Bring. What are your plans, Ryan, for phase 2 and 3?
My plans for phase 2 and 3. I have to say I've done quite an ambitious thing because I'm not using any particular platform. I'm building the platform using for myself and learn how to build robots along the way. I started this project knowing nothing about robotics, and I got to myself here like 2-ish so years later. And
Very
yeah.
good.
That's cool. Anything that you plan on adding to that?
Besides fixing the way it moves itself so that it actually does what it's supposed to do properly, one day in the future it's going to have a robot arm on it that's going to be used to pick up stuff off the floor and drive around, hopefully clean up my room for me.
A worthwhile goal.
Cool. You'll sell 1 million of them.
Like a Roomba but with an arm.
Very good. Thank you, Ryan.
Yeah.
All right. Ross Lunan, are you there? He's on the East Coast in Canada, so he's in midnight land. Mike Wimble, are you ready?
Nope. Way from it, so nothing tonight.
All right. Do we have any more demos this evening? All right, folks, this has been fun. And this, I know a lot of people have put a lot of time, energy, and effort into stuff, and it may or may not have turned out well. So I appreciate it. And like always, it takes a deadline. It takes a deadline to force you to create. So we had some fun. I'd like to thank everybody for participating. I'd like to thank folks for dropping in and viewing and having some fun. It sounds like Chris Mayer is going to be doing the presentation next month on machine learning, and that should be awesome. This is part 2 presentation with a MottBot. And so without any further ado, I'd like to wish you a pleasant evening, and let's keep building those homebrewed robots. Thank you very much.
Thank you, Cam.
Thank you, Cam.
Thanks, Cam.
Thanks, everybody. Good night.
Love you. Bye-bye.
Take care. Bye.
Now we'll just leave the Zoom on for a while for random access, and you could just hang out until security comes and kicks us out.
I gotta go.
Okay, Camp. See you guys later.